this video we are going to see how to construct Galois field 2 raised to 3. This is the extension field from the base field Galois field 2. So for construction of the extension field, the primitive polynomial is needed to be given. So they have given the primitive polynomial. So the 2 points that are important to consider are, we have to express every element of extension field as powers of alpha. Alpha is a primitive element. So primitive element is one whose powers expresses all the elements of the Galois field, and also it is the root of the primitive polynomial. These two features of the primitive element we have already mentioned in one of the video regarding primitive elements features. So primitive element expresses its powers are nothing but all the elements, its different powers are nothing but all the elements of that Galois field, and it is root of primitive polynomial. If it is root of this primitive polynomial x3 plus x plus 1, then x3 plus x plus 1 will be 0 if x equal to alpha. So we have taken alpha cube plus alpha plus 1. We have placed x equal to alpha. So that is equal to 0. That means alpha cube is equal to minus alpha minus 1. In Galois field 2, minus is equal to plus, because 1 plus 1 is equal to XOR operation 1 or addition, 1 plus 1 equal to 0. That means 1 equal to minus 1. So minus we can write it as plus alpha plus 1. So it's after that it is very easy to express every element. So 0 you write it as 0, then 1 as 1, alpha as alpha, alpha square as alpha square. So this is power representation of all the elements, which are the powers of primitive element, and this is polynomial representation of the elements. So when you come across alpha cube, so alpha cube is alpha plus 1, that we have seen here. Till alpha cube you have to write as it is. Then alpha raised to 4 means alpha raised to 4 is alpha cube into alpha. So that is equal to alpha, this alpha, and alpha cube is alpha plus 1. So that is equal to alpha square plus alpha, alpha square plus alpha. Then alpha raised to 5 is equal to alpha raised to 4 into alpha. That is alpha raised to 4 is alpha square plus alpha into alpha. So I have written it first alpha, then alpha cube. Here I have written alpha cube first, then alpha. So this is you can understand this, that alpha into this is alpha cube. Alpha raised to 4 is this one, alpha square plus alpha into alpha. So that will be alpha into alpha square is alpha cube, then plus alpha square. Then again alpha cube is alpha plus 1. So that will be alpha square plus alpha plus 1. And what is alpha raised to 6? Alpha raised to 6 is alpha raised to 5 into alpha. So what is alpha raised to 5? Alpha square plus alpha plus 1 and into alpha. That is equal to alpha cube plus alpha square plus alpha. So what is alpha cube? Alpha plus 1. Then alpha square plus alpha. So this alpha gets cancelled out because 1 plus 1 is equal to 0. So alpha plus alpha is equal to 0. So answer is alpha square plus 1. So these are the elements of Galois field 8. So we have constructed extension field 2 raised to 3, that is Galois field 8, with the help of primitive polynomial, that is x3 plus x plus 1. And this is power representation, and this is the polynomial representation.